Satellite and radio communication.
Satellites are sent into space via spacecraft to orbit the Earth.
To get a successful orbit, the distance from the Earth needs to be precise, so that the centripetal force of the Earth, gravity, balances with the satellite's speed, so it continuously falls around the Earth, more commonly known as an orbit. There are two main types of satellite, GEO Satellites and LEO Satellites. GEO Satellites are geographically stationary above one point on the Earth. This means that they must be orbiting the Earth at the same speed that the Earth is rotating, and they also must be above the equator to be in the same spot above the Earth constantly. Due to the speed that GEO satellites orbit at, they must be at an altitude of approximately 22,000 miles to balance with Earth's gravity, centripetal force. GEO satellites are useful for things such as TV broadcasting, but they are not very useful for collecting information such as the weather or taking photographs, as they are such a long way away from Earth. This is where LEO satellite comes in handy. LEO satellites are low Earth orbit satellites. They orbit the Earth around the poles at a much lower altitude, between 99 miles and 1,200 miles, collecting effectively strips of information about the Earth. Due to their low orbit, they have to be travelling at a much higher speed compared to GEO satellites, because they still have to balance the centripetal force of the Earth. This makes them very useful to gather information, such as the Earth's weather, and to take pictures. To communicate with these satellites, microwaves can be used. This is because they have a higher frequency than radio waves that are used for terrestrial communication, which means that they can carry more information, and waves with a lower frequency get refracted in the atmosphere and ionosphere, whereas microwaves are able to travel straight through. However, there are many other wavelengths and frequencies of radio waves that can be used to communicate with satellites. We can use radio waves to communicate with LEO satellites, giving us control and enabling us to receive images and information. Companies like Sky transmit information to GEO satellites, which is then transmitted back down onto Earth. They use GEO satellites because they can always be seen, as they are always in the same place relative to Earth. In Sky's case, they use a satellite called Astra 2b, which is located 28.2 degrees east. This means that it is 28.2 degrees east along the equator from the meridian line.
Satellite communication is a form of radio communication. One of the applications for terrestrial radio communication is in mobile telephony, communication between mobile phones and the base station connected to a cell mast. There are two main types of cell masts, macro and micro. Cities and towns tend to use lots of micro cell masts. This is because a micro cell mast has a low coverage. However, due to there being many of them, it creates a high capacity. On the other hand, in rural areas, macro cell masts are used because they have a large coverage with a lower capacity. The capacity of a cell mast is determined by sections of frequencies available. So the more masts there are, the more frequencies are available. However, if there are multiple masts in the same area, this can cause interference, as the same frequency will be used for multiple purposes. To visualize this, think of a map of countries in different colours. If you have France, red, Switzerland, green, and Germany, red again, there would be interference of colours between France and Germany. This is because you would not be able to distinguish the border between the two countries. So to solve this, we make Germany blue. However, Hungary can be the same colour as France, which is red, as it does not border France, so there is no interference of colours. This means that although over borders you cannot have the same colour, they can be repeated if they're not in the same area. This is like cell mast frequencies, and that if, for example, two radio stations are using the same frequency over the same area, there will be interference. But if they use the same frequency, not in the same area, i.e. two different areas of coverage, there won't be an interference between them due to how they don't interact. Another way radio transmissions can be affected is by the sun. Generally in the evening, sunspots are more common. This makes the ionosphere more effective, therefore increasing the coverage of the cell masts. A useful feature of radio communication is that if the signal is strong, the cell mast can communicate with your device in such a way that it can tell your device if the signal is strong to reduce the power or vice versa. This means that it can save the battery power of said device and also reduce interference of other signals due to the power output. So, the lower the power, the less interference there will be.